Now we're given a graph that looks something like this and asked to sketch the parabola we think best fits these points. Okay, so I'm going to first show a parabola that doesn't fit these points very well at all. Okay, okay, no good. Not even a very good parabola, but clearly this parabola is very far from a lot of these points. Okay. I'll do another one that doesn't fit very well. Let's see. Okay, well, it could be part of a parabola. That actually comes closer on the average than this one does. Okay, it's an improvement over the first one, but we want the parabola that minimizes the average. It's actually the average squared distance between, it's actually the average squared vertical distance between the parabola and the points. But I'm just going to say the parabola that comes as close on the average to the points, just to give us a ballpark estimate. Okay, and that can be refined. But let's just go ahead and draw that parabola, and I'll draw it in the same. Actually, I want to contrast the colors just a little. Okay. So I'm going to draw a parabola here that I think it probably looks something like this. Okay, well that's not really great. If I lowered it a little bit, it would actually come closer on the average, but let's just take that as our approximation for the moment. Okay, now that's pretty good. If we lower it about that far, it becomes even better. Now, what's the equation if this is y and this is x? And let's go ahead and put a scale on it. The scale that's consistent with that of your graph is here's 0.5, here's 1, here's 2, and so forth. Okay, and here the increments are 0.2, so we've got 0.2, 0.4, 0.6, 0.81, 1.4 up here, and I think 1, 2, 3, 4, 5, 6, 7, yeah, I think I located some of these points a little bit higher than I should have to mimic the graph on the actual document, but that's okay because we want you to get your own estimate. Okay, so let's see. What can we tell about the graph what can we tell about the function that gives you the graph of a parabola that looks something like this? Okay, well, we know that a parabola is modeled by a quadratic function, so that y is a times x minus h quantity squared plus k. We know that the function that models any parabolic graph that opens either upward or downward has to have this form. We just have to find the values of a, h, and k. So what's the value of h and what's the value of k? Well, we know how a parabolic graph can be constructed by translations and shifts of or translations and stretches, that is, by transformations of the y equals x squared function. So if we start with just y equals x squared, which would be down here on the graph somewhere, we go through the 0.11, the 0.00, so it would look something like this. Then we construct the appropriate quadratic function. We can translate it over so the vertex goes from 0, 0 to the x-coordinate of this vertex. That is, our axis of symmetry would go from the y-axis to the axis of symmetry of this graph. So it's going to be very helpful to find the axis of symmetry of this graph. So I'm going to say, okay, here's our axis of symmetry. Okay, and what is our axis of symmetry? There's 0.5, there's 1. I'm going to say the axis of symmetry approximately x equals 0.7. So now if we want to translate a y equals x squared graph so that its axis of symmetry becomes x equals 0.7, that means we have to take the y-axis and move it over 0.7 units, meaning that the vertex, of course, is going to move over 0.7 units in the positive x direction. How does that relate to this picture? Well, we need to translate the axis of symmetry 0.7 units, meaning we have to translate the whole graph 0.7 units in the x direction, and we get that by, when we do, we're going to have the graph of the function y equals x minus 0.7 squared. Now that tells us that h is 0.7. So and I'm not going to re-explain the rules for translations and so forth. We assume you already know those, and if you don't, you really do need to review to see what the rules are and why they work the way they do. Okay, well, having translated the y equals x squared graph over here, its vertex is now on the axis of symmetry. That's real progress because, of course, the vertex has to be on the axis of symmetry, the vertex of the function that we the vertex of the function that represents the parabolic graph that we've sketched. Okay, so next thing we need to do is we need to vertically stretch this graph somehow. Now, I'm not going to figure out the vertical stretch just yet, but we're going to do some kind of a vertical stretch in order for the shape of the graph to either widen or narrow to match the shape of this graph, and also to turn the y equals x squared graph or the y equals x minus 0.7 squared graph around so it's below the x-axis. And we do that, of course, by using a negative value of a. Again, we're not going to figure out that value of a just yet. Let's just figure out the value of k. Once we've applied this stretch by factor a, then all we have to do is raise the graph k units to get to the vertex. Well, if we raise the graph, the vertex from 0, 0 up to this point, how high are we going to raise it? Well, we need to estimate the coordinates of this point. Now, I estimate the coordinates of this point to be what? I'm going to say, well, it has to be 0.7 because our axis of symmetry is 0.7. Here's 1.4, 1.6 would be up here. I'll view that line a little bit. I'm going to say it's at 0.7, 1.5. Well, what does this mean? This means that we have to raise the graph, the vertex, from the x-axis where y equals 0 up to 1.5. So we're going to have a vertical shift of 1.5, and that's easily accomplished if we just add 1.5 to whatever we get here. Okay, because whatever we get here is still going to have a vertex at 0 even after we multiply by a. But then when we add 1.5, that's going to move the vertex up to y coordinate 1.5. So we raise y equals a times x minus 0.7 squared, where a is some as yet undetermined number, which does need to be negative. We raise this by 1.5 units in the y direction. How do you do that? Well, y has to become 1.5 greater, so we just add 1.5 to our y value. Our y value is a times x minus 0.7 squared, so our function is going to be y equals a times x minus 0.7 squared plus 1.5. Okay? Now, we still don't quite have the function because we haven't evaluated a, and this is the thing that actually takes a little more work. What we've done so far is basically just reasoned out what we ought to know about translations, which is that if the origin, if the vertex is going to go from the origin to the point 0.7, 1.5, h is going to have to be 0.7 and k is going to have to be 1.5. h, k are the coordinates of the vertex of this graph, no matter what the value of a is. Okay, well, we still need to find A. So how do we find A? To find A, we just have to estimate 1 point on our graph. So I'm going to find A by estimating 1 point other than the vertex because we've already used it. And the point I'm going to use is, I could use, and I probably would use 0. That looks like about 1 point. What do you think? That's 1.2 and 1.4, and 1.3 would be here. I would say that's probably about 1.0. I'm sorry. Yeah. I know what I did wrong here. This isn't 1.4. No, this is 1. Okay. Sorry. That's about 1.23, let's say. So this point might be 0, 1.23. I could use that point, and all I would have to do is plug in 0 for x and 1.23 for y, and I'd have an equation I could solve for A. Now, I wasn't going to use that because I didn't want anything to become 0 and simplify the process, but actually, since 0 is going to be substituted for x, we're still going to have to square the 0.7. I've changed my mind. So I'm going to use 0, 1.23. So estimate this as a point on the graph. Now, by a point on the graph, I mean a point on our graph of our function. The data point here is 0, 1.2. The parabola intersects the y-axis a little bit above that point. We're going to use the point on the parabola, not the data point. We never use a data point as a basis for anything once we've constructed our parabola. So we estimate this as a point on the graph, and then we plug this in and solve for A. So for this point, that means we're going to plug in 0 for x, 1.23 for y. We're going to get from this equation then 1.23 equals A times 0 minus 0.7 quantity squared plus 1.5. And at this point, it's very easy to solve this equation. You should do that. I'm going to write out the solution, but you should pause and solve the equation just to reinforce what we're talking about. Okay, 0.7 squared is 0.49, so we get 1.23 equals 0.49a plus 1.5. I'm going to subtract 1.5 from both sides, then divide by 0.49. I've done all that in one step. We get negative 0.27 over 0.49 equals negative 0.55. So now our y equals a times x minus 0.7 squared plus 1.5 function becomes y equals negative 0.5 times quantity x minus 0.7 quantity squared plus 1.5. That's the equation for this parabola and for this model of our data points.